Hello and namaste to everyone. So today we are going to move on to the next topic of arithmetic progression, which is nth term of an AP. We have already discussed this formula in our previous videos and how we have derived this formula. So this is what we are going to discuss today, and we are going to do questions based on this formula. Before starting exercise 5.2, I would like to discuss the examples which you have in your NCERT textbook, that is class 10 NCERT textbook. That is what we are using for reference. So first we are going to discuss examples, which is example 3 to 10 of chapter 5, and then we are going to move on to exercise 5.2. So if you remember from last video, we discussed about nth term of an AP, and we discussed the formula, which is an is equals to a plus n minus 1 into b, where a is first term of an AP, b is common difference, and n is the terms which we want to calculate: first, second, third, and so on. If for example there are m terms in an AP, okay, if for example there are m terms in an AP, then m term, like mth term, will be the last term of that AP, right? So that mth term is often denoted as AL is equals to AM, where AL is last term of an AP which has m terms in it, which is equals to A plus n minus 1 into D. When AP has m terms in it. The formula for this and this is same, but nth term is called as general term of an AP, and mth term, when AP has m terms in it, is called as the last term of an AP. I'm just giving you these notations so that you are not confused when you see it in your textbook. We'll quickly move on to example 3 now. Example 3, page number is 102. Find the 10th term of an AP 2, 7 and 12. So basically an AP is given 2, 7 and 12, and you have to find 10th term of this AP. So A10 is equals to, so from formula AN is equals to A plus n minus 1 into D. Can I write n as 10? Right? So A10 is equals to A plus 10 minus 1 into D, which is A10 is equals to A plus 9D, correct? What is A here? A is nothing but 2. So A is equals to 2. And what is D here? 7 minus 2, which is equals to 5. So I'm going to put these values and see what we have as an answer. A10 is equals to 2 plus 9 into 5, right? 2 plus 9 into 5, that is 2 plus 45. 45 plus 2 is 47. So A10 is basically equal to 47. Okay. Let's move to next question, example 4. Which term of an AP 21, 18, 15 is minus 81? Also, is any term 0? Give reason for your answer. So this is an important question and you should note the simple concepts which are used here. 21, 18 and 15. Now what we have in our question? They are basically asking first part of question is you have minus 81 as a term. They are asking which term would this number be in this AP? Like which term would it be? Will it be first term, second term, third term or fourth term? So clearly we can see that we have been given AN, right? Let us suppose this is nth term of an AP, right? Let us suppose minus 81 is nth term of an AP. Then clearly AN is equals to minus 81. A is equals to what? 21, right? And what is D? 18 minus 21, which is nothing but minus 3. Now let's use that formula. AN is equals to A plus N minus 1 into D. Can I write it like this? What is AN? Minus 81 is equals to 21 plus N minus 1 into D. What is D? D is minus 3. So minus 81 is equals to 21. Multiply this with this. That is minus 3n, because this is minus, so this sign will change. Minus 3n plus 3. Okay? 21 plus 3 is what? 24. Minus 81 is equals to 24 minus 3n. Right? So minus 81 is equals to 24 minus 3n. Minus 81 minus 24 is equals to 3n. 4 and 1 is 5. 8 and 2 is 10. Why I am adding this? And why minus sign is here? Because we are moving it to left hand side. So sign will change and this will become minus 24. Minus terms, both terms will add. That's why this will become minus 305 is equals to minus 3n. Right? Right? Minus both the sides. Minus cancel. 105 is equals to 3n, which is nothing but 105 divided by 3n. 3 3s are 9, 3 5s are 15, and clearly n is equals to 35. So minus 81 is the 35th term of this AP. Now second part of this question is also is any term 0? See, we can clearly see in this question the common difference is negative, right? So basically the terms are reducing. 21, 18, 15, so it is reducing. So it is possible that one term in this AP can be 0. But now we have to check which term will be 0 or will there be any term which will be 0. So first, will it be any term which is going to be 0? And second, which term will that be if it is 0? So how are we going to check? Using the same method. Let us suppose nth term of this arithmetic progression is 0. Okay? Then an is a plus n minus 1 into d. Right? An is supposed to be 0. This is 21 plus n minus 1 into minus 3. So 0 is equals to 21 minus 3n plus 3. So 0 is equals to 24 minus 3n. Taking 3n to this side, I get as 24 is equals to 3n, which is 8. So n is equals to 8. See, in this case, as this n is equal to 8, hence 8th term of this AP is going to be 0. But assume if this n would have come 8.5 or 9.5, then that n is not an integer. So if it is not an integer, then it cannot be the term of an AP. right? So this is how you have to reason in the question. If n is coming as an integer, okay, then definitely 8th term of this AP is going to be 0. But if n is coming as a non-integer value, then that 0 is not going to be the part of an AP. Let's move on to the next example. Example 5. Determine the AP whose 3rd term is 5th and 7th term is 9. Very interesting question. So now they are saying that you have to determine an AP whose 3rd term is what? 5 and 7th term is 9. So can I write this as A3 is equals to 5 and A7 is equals to 9? What is A3 going to be equal to? A3 will be equals to A plus 3 minus 1 into D, which is going to be A plus 2D, and A7, A plus 7 minus 1 into D, which is A plus 60, right? So, A plus 2D, right, from this and from this, from 1 and from 2, I can write here from 1 and 2. I clearly get A plus 2D is equals to 5 from 3 and 4. I get A plus 60 as 9. Correct? Now let us say this equation as 5th equation and now this equation is 6th equation. So basically what we have to do, we have 2 equations and 2 variables. So we just have to solve these questions and we'll have value of A and D with which we can determine this AP. So now let us see how are we going to solve these 2 equations. This was our 5th equation, this is our 6th equation. I am going to subtract equation 5 from equation 6. This is what I am going to do. Then clearly I can have from left hand side A plus 60 minus A plus 2B will be equals to 9 minus 5. A plus 60 minus A minus 2D. 4. A cancel. 60 minus 2D is what? 4D is equals to 4, right? So D is equals to nothing but 1. Okay? Now we are going to put this value in any of this equation and you will get the answer. So let us put D equals to 1 in 5th equation. Then I get A plus 2 into 1 is equals to 5. A plus 2 is equals to 5 and A is equals to 5 minus 2, which is equals to 3. Now if you have an equation where A is equals to 3 and common difference is equals to 1, then what is going to be series of that AP? 3, comma 3 plus 1, which is 4, comma 4 plus 1, which is going to be 5, comma 5 plus 1, which is what? 6. So what is going to be the arithmetic progression? 3 3, comma 4, comma 5, comma 6, comma 7, comma 8, and so on. Okay, so that's how we have found the arithmetic progression when two terms of an AP are given to us. Okay, let's move to next question, that is example 6th. Check whether 301 is a term of the list of numbers 5, 11, 17 and 23. Okay, now in this question, read the question very carefully. Check whether 301 is a term of the list of numbers 5, 11, 17, 23. Now here they are clearly saying that you have a list of numbers. So don't assume that you already have an arithmetic progression here. First point in this question is to check whether this is an arithmetic progression or not. For example, suppose if you start solving this question without checking whether it is an arithmetic progression or not, you may end up doing the question incorrectly. Okay, so let's check. Example 6. What we have to find out, that there is a list of numbers 5, 11, 17 and 23. And we have to check whether 301 is their term or not. Like 301 will come in this series or not. First, let us check whether this is an AP or not. For that, what we'll do A2 minus A1, which is 11 minus 5, 6. A3 minus A2, 17 minus 11, 6. And A4 minus A3, 23 minus 17, which is also equal to 6. So 6, 6, 6, 6. So now we can see the common difference is same, right? So as the common difference is same, as the difference is same between all these terms, so that is going to be an arithmetic progression with a common difference of 6, right? And what I have to check whether 301 is term or not. So basically I have to check whether 301 is going to be its term or not, and we discussed this question, I think we discussed this in example 4 also, but with the number 0, whether it is its term or not. So with the same process, we will proceed with this question. 301 is term or not. So let us suppose 301 is nth term of an AP, nth term of this AP. So an is equals to 301. When I am saying 301, it's 301. So an is equals to 301, which is equals to a. That is 5 plus n minus 1 into d is nothing but 6. So 301 is equals to 5 plus 6n minus 6, right? 6n minus 6, multiplying this by this is positive, so no problem. So 301 is nothing but 6n minus 1. 5 minus 6 is what? Minus 1. This minus 1 will move here. So I will have 301 plus 1 is equals to 6n, which is 3 over 2. That is 302 is equals to 6n. Now 302 divided by 6 is going to be equal to n. Now, is this divisible by this number? No. You can clearly see 302, 6 5s are 30, cancel, and you have 2 remaining here. So if you will be 50.20, well, that will be 60. 3s are 18 and something again 2, so 50.33. N is equals to approximately 50.33. Can n be equal to non-integral value? No. N cannot be equal to non-integral value because n is basically the number of terms which we have in an AP. So n can only take integral values and cannot take non-integer values. Therefore, 301 is not going to be the term of this AP. So with this we have finished till example 6.